Alright, we will start solving problems then. Okay, so question number 1 is the maximum acceleration of a particle in vibrating mode is 16 centimeter per second square, and the maximum velocity is 8 centimeters per second. So the question is, find time period and amplitude of oscillations. So they have mentioned about the velocity and the acceleration. Maximum values are given. So we can see that acceleration max, the maximum acceleration, we know that this is omega square times a. So this is given as 16 centimeter per second square. And you can see that the velocity is given. We call this is u max. So what is u max? This is nothing but omega a. This is given as 8 centimeters per second. Okay, now so omega square a has a omega a, correct? So we know that omega square a is equal to, I can write omega square a, which is equal to 16. So I can write omega square a is omega into omega a. That is equal to 16. But from this I know that omega a is 8. So that means omega into 8 is equal to 16. So 8 cancels 16 with 2. So we got our answer as omega is equal to 2. Okay, so this is radians per second. The unit for omega is radians per second. So when I know this, I can actually calculate the omega a is 8. This implies 4 times a, sorry, not 4, 2. So this implies 2 times the value of a is 8. So a is equal to 4. This is centimeters. So the question is to find the amplitude. We got that. And now the question is to find the time period. So you see omega is known to us now. Omega is equal to 2. This is equal to 2 pi divided by capital T. Right? So where T is the time period. So 2 cancels and T goes to other side. So this implies T is equal to 5 seconds. That is the required answer. Alright, let's move on to the next question. A linear oscillator has the total mechanical energy of 200 joules. The potential energy of the same at the mean position is 50 joules. So the question is to calculate the following. Part A of the question is the maximum kinetic energy. Okay, then part B of the question is the minimum potential energy. Then part C of the question, potential energy at extreme positions. So what they have given is the mean value is mentioned. Okay, so I will write U minimum. So potential energy is minimum and kinetic energy is maximum at the mean position. Okay, so this is the basic idea. We know that there is a oscillation that is happening, linear oscillation. So kinetic energy is maximum at the mean position and the potential energy becomes minimum at that point. So we'll write that point just to understand. At mean position, so if you are considering the mean position of an oscillator, right, its potential energy, I'm writing PE, is minimum. Okay, and at the same time you can see that velocity will be maximum at the center. That's why you have the kinetic energy is the maximum value. This is where at the center. Therefore I can write now the minimum U value, U min, is given, which is 50 joules. So which means I can write the kinetic energy maximum value is nothing but 200 minus 50. So this is equal to 150 joules. Straightforward answer. It is again at the mean position only. Now you see that at the extreme positions there is no kinetic energy because the whichever particle is oscillating, that is its velocity is zero at the extreme position because it has to turn back and go to the path in which it was coming earlier, right? So now we'll write that point. So at the extreme at the extreme position, what we are considering, right? So at that extreme position, we know that the kinetic energy is 0 and the potential energy is maximum. So this means we have only U max at that. So U max is nothing but the energy itself, that is given as 200. So 200 joules of potential energy we can see at the extreme condition. So whatever they have asked, we solve it. Okay, then let's go to the next question. All right. If a particle is executing simple harmonic motion, then what fraction of the total energy is kinetic and what fraction is potential when the displacement is half of its amplitude. All right, this is the first question. Then we have another question, that is, at what value of the displacement r the kinetic energy is equal to potential energy? So we have two questions here, right? There is a particle which is vibrating and following the simple harmonic motion, right? So let us start the solution from the minimum potential energy position, that is the mean position. So at the mean position, right, we know that the potential energy is minimum. So we know that the total energy, I can call it as E total, is equal to half of m omega square into capital A square, right? So out of this there is a kinetic energy fraction. This is equal to half of m omega square into a square minus x square, right? And we know the equation for potential energy, that is half m into omega square x square. All right, so the first part of the question says that at a given point, that is x is equal to, at a distance, that is half of a, so that is a by 2, right? So we have to calculate, this is first part of the question, at a is equal to, sorry, at x equal to, displacement is half of the amplitude, so a by 2, we can calculate the kinetic energy is equal to, let's substitute, this is half m into omega square into this is a square minus this is x square, so this is a square by 4, correct? So what happens to the kinetic energy now? So this is I can write half m omega square, so this is 4 minus 1, that is 3a square by 4 is a term. This is the kinetic energy. Okay, so if you want, so the question says that how much out of the total energy, what percentage is kinetic energy? So this implies the kinetic energy divided by E total is equal to, so kinetic energy is half m omega square into 3a square by 4 whole divided by E total. You can see the above equation, this is half m omega square a square. So we can cancel these terms, half m omega square, half m omega square, and a square, a square. So this gives me an answer. Kinetic energy is 3/4 of the total energy. This is the ratio. Okay, at the same time, now I need to calculate u at a given point. So u is equal to, right, this is half m omega square into x square. You can see that x is a by 2, so this is a square by 4. Let's keep this as it is. So this implies, once again, I am calculating potential energy by total, that is equal to, so numerator is half m into omega square into a square by 4 whole divided by half m omega square a square. So if you check this, this cancels, a square cancels. So that means now I'm left with only 1 by 4. So you can see that the potential energy is 1/4 of the total energy at that point a x equal to a by 2. Now you see we have the second part of the question. I'll write as B. So they say that the kinetic energy is equal to potential energy. That means let's write the equations now. Kinetic energy is given by half m into omega square multiplied by a square minus x square. This should be equal to half m omega square into x square. So once again, whatever terms we can cancel will cancel. So half m omega square cancels with half m omega square. So what is that? This means it is a square minus x square equal to x square. So x square goes to other side. You have 2x square equal to a square. So this means x square is equal to a square by 2. So that means x is equal to root of a square by 2, that is a by root 2, right? So 1 by root 2 is 0.707 times a. So when kinetic energy becomes equal to the potential energy, the displacement is 0.707 of the total a. Okay, so that is the question, and anyway, now we have the answer. All right, then let's try to calculate another problem. All right, the next question is this. And oscillation is represented by x equals to, this is 10 sine pi t plus pi by 6. Find the amplitude, period, and the maximum velocity. So always we need to compare. Let's write the equation. X is equal to 10 sine pi t plus pi by 6 should always be compared with a into sine of omega t plus phi. So I can see that they are asking the amplitude, which is a, which is given as 10. Okay, then I can equate both terms to get the values of omega. So what I compared this value with this, and now I am comparing this omega, which is with the t, I'm equating with pi. Okay, so a is 10, direct answer. SI units is meter, so you can write that, and omega is equal to pi. Okay, this implies, so omega is what? Omega is 2 pi by capital T. This is given as pi. So pi cancels, t goes to other side. So time period is equal to 2 seconds is the answer. Then what is the maximum velocity? So remember, V max is nothing but omega times amplitude. Okay, so omega is how much? Omega is equal to, just now we calculated, this is 2, and capital A is sorry, omega is not, t is equal to this, so omega is actually pi, sorry, my mistake. So we can write in this way, this is equal to, omega is pi and amplitude is 10, so this is 10 pi velocity, so this is meters per second. All right, then the next question. A particle executes simple harmonic motion with capital T is equal to 4 seconds. Find the time taken by the particle to go directly from mean position to half of amplitude. So we need to calculate the time, how much time it's going to take. Right, now let us assume that particle starts from the mean position and moves in one particular direction. So we can say that the displacement x is equal to a amplitude into sine of omega t. This is a general equation. Now they say that the displacement is half of this. So a by 2 is equal to a into sine of omega t. Okay, So this means a cancels. So sine omega t is equal to half. So this implies if you want to calculate omega t, this should be sine inverse of half. So what is sine inverse of half? This means omega t is equal to sine inverse of half is pi by 6, 30 degrees. Okay, now if you want to calculate the time t, this is equal to t is equal to pi by 6 times omega. Okay, now I don't know omega, but I have been given the capital T value. So let's substitute that. That is pi divided by 6 into, see, this is 2 pi by capital T, right? So we can say that this is pi into capital T divided by 12 pi. Okay, let me write this and this cancel. So substitute for capital T, because capital T is given as 4 in the question, 4 by 12. This is the required time. So this cancels as 3. So this is 1 by 3 second. So in 1 by 3 second, it covers the required distance. All right. That's the solution of this. Okay, let's go to the next question. All right. A particle is vibrating about a point x equal to 0 at t equal to 0. Its displacement is x equal to 2 centimeters and velocity equal to 0. So if the frequency is 0.25 per second, then calculate part A of the question, period. Part B of the question, angular frequency. Then part C of the question is amplitude. Then part D of the question is maximum velocity. Then part E of the question is displacement at t equal to 3 seconds. Part F of the question, velocity of the particle at t equal to 3 seconds. Okay, the important question. So these kind of questions are pretty common. Okay, so let's answer the question number A. It's a straightforward. They are asking what is the period. That is capital T is 1 by frequency. So frequency is given. So this is nothing but 1 divided by frequency is 0.25. So 1 by 0.25 is 4. So period is 4 seconds. Part B of the question, they are asking what is the angular frequency. So that is omega is equal to 2 pi by capital T. So substitute. This is 2 pi by 4. This is equals to pi by 2 radians per second. Right? Angular frequency. Angles covered is pi by 2 radians per second. Okay, 90 degrees it's going to cover. Right. Now, part C of the question. It says that amplitude of the maximum displacement, right? So that's what is the amplitude. It's a maximum displacement. So amplitude A is equal to, see the distance is given 2 and the mean position is 0. 2 minus 0 is 2, right? I think everything is measured in centimeters, so we'll write in centimeters. Okay, next. Part D of the question, it says maximum speed, right? Maximum speed V max is equal to omega into A. So omega is pi by 2 into A is 2. So 2 to cancel. So V max is pi units in centimeters per second. Okay, next. We can see that the part E of the question says that we are supposed to find out displacement from the mean position at t equal to 3. Right. So at t equal to 3, if you want to find x, I need to use this is the equation. X is equal to, see, actually we have two types of oscillations, right? Maybe we have oscillation starting from this side, it goes till here and comes back, right? So if it start from left and moving to right, we assume that direction of sine. This is sine direction. If it start from rightmost and comes back, then that is considered as the cosine motion. All right. So now you see that it actually at t equal to 0, you can read the statement. The displacement is from x equal to 2, which means x equal to 0 will be at the center, x equal to minus 2 will be at this. So it actually starts from rightmost. So this has to be a cos function. So we'll write x is equal to a into cos omega t. Right? So the displacement is given by a is, in this problem it is 2 into cos omega is known, which is pi by 2 radians per second into t. Right. Now what you do, you put x equal to, put at t is equal to 3 seconds, x is equal to 2 times cos of 3 times pi by 2. Right? Cos 3 pi by 2 is 0, so x equal to 0. So at 3 seconds, this is exactly at the center. Okay, then part F of the question, right? At x equal to 0, because at 3 seconds, the body is at the center, x equal to 0, the velocity equal to V max. It will be at, with its maximum velocity, already we have calculated, that is pi centimeters per second. So this is the required answer. All right. Let's move on to the next question. Okay. Uh, Fine. Next question is this one. It is the acceleration of a particle continuously vibrating at x equal to 10 centimeter from the mean position is A is equal to minus 2.5 centimeters per centimeter square. Centimeters per second square, sorry, second square, yes. Find period of oscillations is a question. So we know that there is a direct answer to this. T is equal to 2 pi into the square root of, this is magnitude of x by a. So we can substitute this 2 pi, right, into square root of, neglect the sign, this is 10 is the distance, and 2.5, it's minus 2.5, but anyway there is a magnitude for that, so 2.5 cancels 10 with 4, so root 4 is 2, so 2 into 2 is 4 pi, so the time period t is equal to 4 pi seconds. Alright, that's a straightforward answer. Next question. A block with mass 3 kg is suspended from a spring of negligible mass, and stretches the spring by 0.2 meters. We have two questions inside this. So first question is, find the force constant of spring. That is part A, and part B, find the period of oscillations when reached. Okay, so to answer the first part of the question, we have to equate the spring constant into its length should be equal to the mass into the force, acceleration due to gravity. So this implies if you want to calculate K, then this should be mass into G divided by L. So mass is given, this is 3 into G is 9.8 divided by length is equal to 0.2. So what is K now? So K is equal to 3 into 9.8 by 0.2. This means it is 147 newtons per meter. Okay, now part B. We can calculate the T by using this is equal to 2 pi into root of m by k. So this is equal to, or actually m by k is same as from the equation we know that m by k will be equal to L by G. You can also use that. Okay, but anyway, this is fine. We know the values. We can directly substitute. This is root of, you see, m is equal to 3. Okay, and k is equal to 147. So the T comes to be equal to 0.897 seconds.